Welcome back to Darter's Education. Sometimes, a circuit looks impossibly hard. You have voltage sources here, current sources there, and resistors everywhere. Applying nodal or mesh analysis might give you 5 or 6 equations. Ideally, you want to avoid that. What if I told you that you could change the shape of the circuit without changing its physics? What if you could turn a voltage source into a current source, just by following a simple rule? This is called source transformation. It allows us to simplify complex networks, step by step, until they become trivial. It is the art of circuit shapeshifting. Imagine you have a messy spaghetti of wires. Source transformation lets you eat that spaghetti one deliberate bite at a time, until the plate is clean. By the end of this video, you will be able to look at a complex ladder network and collapse it into a single loop in seconds, without writing a single simultaneous equation. Let's look at the two fundamental building blocks. First, the practical voltage source. This is an ideal voltage source Vs in series with a resistor Rs. Visualize this clearly: a battery and a resistor holding hands in a line. Second, the practical current source. This is an ideal current source, Is, in parallel with a resistor, Rp. Visualize this as a current pump with a leak path right next to it. Source transformation states that these two are equivalent if they produce the same voltage-current relationship at their terminals. Here describes the magic formula, Ohm's law. Vs equals Is times R, or Is equals Vs divided by R. The resistor stays the same. The value of R in series becomes the exact same value of R in parallel. Rs equals Rp. But be careful with direction. The head of the current arrow corresponds to the positive terminal of the voltage source. If the arrow points up, the plus sign is on TOP. If the arrow points right, the plus sign is on the right. If you remember arrowhead equals plus, you will never get the sign wrong. Why do we care? Because simpler is better. Imagine you have a node where 3 branches meet. One branch has a 10-volt source in series with 5 ohms. Another branch has a 2-amp source in parallel with 10 ohms. You cannot just add them. They speak different languages, but with source transformation we can translate them. Step 1. Transform the voltage source. Take that 10 volts and 5 ohms. 10 divided by 5 is 2, so it becomes a 2-amp source in parallel with the 5-ohm resistor. Step 2. Combine. Now look at the circuit. You have 2 current sources in parallel. If they both point up, you just add them. 2 amps plus 2 amps makes 4 amps. You also have 2 resistors in parallel, 5 ohms and 10 ohms. Using the product over some rule, 5 times 10 is 50. 5 plus 10 is 15. 50 divided by 15 is 33 ohms. Step 3. The result. You have simplified that entire messy section into one single 4-amp source and one single 33 ohm resistor. This is the power of the method. Transform, combine, transform, combine. It creates a domino effect. Suddenly, a messy 5-node circuit collapses into a simple 1-loop circuit. Let's try a classic ladder problem. We want to find the voltage V out across the last resistor on the far right. Let's call this 8-ohm resistor the load. Strategy: we start from the far left, away from our load. We are going to eat the circuit from left to right. Stage 1. On the far left, we see a 40-volt source in series with a 10-ohm resistor. Transform it. 40 volts divided by 10 ohms gives us 4 amps. So now we have a 4-amp source in parallel with the 10-ohm resistor. Stage 2. Look what happened. That 10-ohm resistor is now in parallel with the next vertical resistor. Let's say it is 40 ohms. Combine them. 10 in parallel with 40 is 8 ohms. Now our circuit is simpler, but we have a current source and a resistor in parallel. Stage 3. Transform back to a voltage source. 4 amps times 8 ohms is 32 volts. So now we have a 32-volt source in series with an 8-ohm resistor. And look, it is now in series with the next horizontal resistor. We repeat this process. Transform, combine, until eventually the entire left side of the circuit is just one voltage source and one resistor attached to our load. Then, finding V out is a simple voltage divider. Critical rule: never transform the component you are solving for. If we had transformed the load at the beginning, the variable V out would have vanished into the math. Keep the load safe. What about diamond sources, dependent sources? Can we transform them? The answer is yes. The math is exactly the same. V equals I times R. But there is a trap. A dependent source relies on a controlling variable somewhere else in the circuit, usually called Vx or Ix. Imagine Vx is the voltage across a specific 2-ohm resistor in the middle of the circuit. If you decide to combine that 2-ohm resistor with another one, or transform it, Vx disappears. If Vx disappears, the dependent source that relies on it becomes undefined. The equation breaks. So the rule is, you can transform a dependent source itself, but you must never touch the branch that contains the controlling variable. Draw a red box around it. Do not touch inside the red box. Everything outside is fair game. Source transformation is a tool of elegance. It saves you from writing matrices. It saves you from solving simultaneous equations. Remember the 4 commandments. 1. Series voltage equals parallel current. 2. The resistor value does not change. 3. Arrowhead equals positive terminal. 4. Don't touch the load or the controlling variable. If you mastered this, you are ready for the Venon's theorem, which uses this exact principle to simplify entire networks into a single source. We are building the ultimate library for engineering students. If this helped you see circuits differently, hit like and subscribe to Darter's Education. Happy engineering!